The first one in part B says, what is the probability that at least one marble is red? Well, let's see. At least one is red. Let's see where that happens. It looks like it happens there. There's two reds. Happens there. There's a red. Happens there. There's a red. Happens there. There's a red. And so the probability of at least one red is what we will add up here. So let's add those up. It looks like we have 1 out of 6, 1 out of 6, 1 out of 6, 1 out of 6. So it looks like 4 out of 6 is the probability of getting at least one red. That makes sense. Out of the 6 choices, 4 of them have at least one red. Down below, what's the probability that both marbles are the same color? Again, let's look at our sample space, and both are the same color. Well, here's GG, green, green. Here's red, red, RR. Both of them are the same color in that case. And so the probability that they're both the same color, I either have to get red, red, or red, green. 1 out of 6 chance of getting the 2 red, 1 out of 6 chance of getting the 2 green. That's a 2 out of 6 chance that I will get both marbles the same color. And again, that makes perfect sense. If you look at our sample space, out of the 6 possibilities, 2 of them have the same color. Finally, they're asking us to find the probability that at least one of the marbles is green. So let's see what we have here. At least one is green. That happens here, 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 and here. 4 out of the 6. So the probability that at least one of them is green is 4 out of 6. So let's pull up our pen again, and it's 4 out of 6. Those are the possible ways that we could have at least one green. So the lesson to be learned here really is that tree diagram can be very helpful. You use the counting principle to determine your sample space, RR, RB. We multiply those probabilities, and then we just add up the ones that we want in order to answer the question. Example 7, I'm going to leave for you to do. We're tossing 2 dice, and they ask us to draw a tree diagram. Here's the tree diagram, and we have a 1 out of 36 chance of any individual thing happening. For example, we saw earlier that the 1 and 1 had a 1 out of 36 chance. They want us to find several probabilities. The probability that the sum of the 2 numbers is 8, the probability that the sum is greater than 11, the probability that the sum is divisible by 10, and the probability that the sum is a multiple of 3. I'm going to leave this for you to do. You can construct the tree diagram and give these a try. Pause right here, and once you're done, we'll take a look at the solutions. Let's take a quick look at the solutions. The probability that the sum of the 2 numbers is 8 happened 5 out of the 36 times in our sample space. So 5 out of 36, or 0.138 repeating, is our probability that the sum is 8. The probability that the sum is greater than 11 happened 2 out of the 36 times. And so 2 out of 36, or 0.05, is the probability for number 2. Number 3, the probability that the sum is divisible by 10, that happened a total of 3 out of the 36 times. That was when our sums were 10, 20, or 30. And the probability that the sum is a multiple of 3, that happened 12 out of the 36 times, or about 0.3 repeating, or 1/3. So there are the solutions to example 7. Our last example, example 8, we have a family moving in next door. And we've heard that they have 3 children. And we have some girls, some boys, but we don't really know how many are boys or how many are girls. But there are 3 of them, and so we can do a tree diagram. And we'll just do the first child, the second child, the third child. The first child could have been a boy, and there was a 1/2 chance that the first child's a boy. The first child could have been a girl, and there was a 1/2 chance that the first child was a girl. So first kid, either a boy or a girl. Now let's look at the second child. The first child being a boy doesn't really have any impact on what the second child will be. The second child could either have been a boy or could have been a girl. The probability of having a boy was 1 out of 2. The probability of having a girl was also 1 out of 2. Or maybe the first child was a girl. Well, the second child could have been a boy. 50% chance there, 1/2 probability. Or the second child could have been a girl. And so here we have our tree diagram coming together. So we have a boy then a boy then a girl then a boy, or a girl then a girl. There's a third child though, and so let's draw those branches of our tree. Okay, so the third child could have been a boy, and there's a 50% chance it was a boy. Or it could have been a girl, again, 50% chance of that. And I think you see the pattern we're getting at here. We're just going down, filling in the possible choices for the third child. And we'll just go right down, we'll fill that in. And isn't this fun? And so here's all the possibilities. We could have had a boy, then a boy, then a boy. We could have had a boy, then a girl, then a girl. We could have had a boy, boy, girl. We could have had a boy, girl, boy. Or it could be a girl, then a boy, and another boy. Or a girl, a boy, and then another girl. A girl, then a boy. Or my sister's dream, all 3 girls. So there are the possible things that we could have. And we can list out our sample space off to the side. Boy, 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 girl, etc. Let's list that out off to the side. Let's do that right now. So here's my sample space right off to the side here. I've got all the possible things I could have. Boy, 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 a boy, then a girl, a boy, then a girl, then a boy, a boy, then a girl, etc. And I multiplied the probabilities, a half times a half times a half, to get the probabilities that correspond to each of those selections. Once I have this is really the hard part. The questions they're asking us are, first of all, the probability that the family contains 2 girls and 1 boy. Well, let's see where that actually happens. All right, so let's take a look. We want to know 2 girls and 1 boy. Well, here's 2 girls and 1 boy. Here's 2 girls and 1 boy. Here's 2 girls and 1 boy. So it looks like 1/8, 1/8, 1/8. And so all I've got to do now is go down and say, okay, 2 girls and 1 boy. Well, that was 1/8 plus 1/8 plus 1/8. And so we add those up. There's a 3 out of 8 chance that the family has 2 girls and 1 boy. Let's pause here. Please take a moment to answer questions 2 and 3, the probability that the family contains at least 1 boy, and the probability that the family contains at least 2 girls. Probability that we contain at least 1 boy. At least 1 boy happens in several of these sections here. There's at least 1 boy there. Remember, at least means 1 or more. So at least 1 boy in all of these cases, and in fact, 7 out of 8 times there's at least 1 boy. So probability of at least 1 boy is 7 out of 8. Now, let's take a look at the family contains at least 2 girls. Well, 2 girls. Let's see, where do we have 2 girls? So there's 2 girls there, 2 girls there, 2 girls there, and it says at least 2, so I could have 3. So there's 4 different places, 1/8 plus 1/8 plus 1/8 plus 1/8. So my probability in this case is 4 out of 8. And so there are my probabilities for these 2 examples, 7 out of 8 and 4 out of 8. That is how, ladies and gentlemen, we use the counting principle in order to work with compound events. Remember, compound events are simply things that are independent of each other, meaning what happens the first time doesn't impact what happens the second time, and we use the counting principle to find those probabilities.